So here we've got a algebraic question. You have a function which we're told is odd, fx, which is positive for all positive x. And the integral from 0 to a of fx dx is e to the a plus 1 over e to the a minus 2 for a positive, which means x positive as well. And you want to find the area bound by y equals f of x plus 4, and the straight lines x equals 5 and negative 5, and the x-axis. Right. So we will probably benefit from having a diagram to look at here. Now, you don't know a whole lot about this, apart from the fact it's odd. But basically, whatever you've got, it's odd. So just give you some rough idea. So if this is y equals fx, fx is positive for all x positive, so something like that. So if it's positive for all x positive, then it's probably has to be a strictly, well, it might not have to be a strictly increasing function, but it will have something like this. So you can think of, for example, to give some idea, this is some idea of what it might look like. And see, the thing is, you're asked to find the area bounded by y equals f of x plus 4, which is not fx, but x plus 4. And the straight lines x equals 5 and negative 5, and the x-axis. But see, if fx is like this, hypothetically, then f of x plus 4 means you shifted fx to the left by 4. Right? It's just your curve sketching transformations. So you'll have negative 4, and you'll have something that looks like this, just in terms of what it looks like. So this is y of equals f of x plus 4. So if you're trying to find the area bound by y equals f of x plus 4, and the straight lines x equals 5 and negative 5, so we'll call that not to scale, because this is a very rough diagram. If we call this 5 and negative 5, then you're really looking for this and this area, right? You're really looking for that area. But then that's equivalent to you kind of just working out from negative 1 over here to 9 over here. Right? That's equivalent, right? Because it's that same area, and that is like, if you think of this as 0 to there, it's just the same as 0 to 9. So in other words, I'm saying that for all intents and purposes, you're basically trying to get area 1 and area 2, where area 1 is the integral of f of x plus 4 dx from negative 5 to negative 4, well, absolute value. And area 2 was the integral from negative 4 to 5 of f of x plus 4 dx. But that's really equivalent to the negative of the integral from negative 1 to 0 of f of x dx. And this is equal to the integral of 0 to 9 of f of x dx. And I've shown you that sort of graphically. But we could have done this purely algebraically. And let me show you what I mean by that. So it might not have made a whole lot of sense if I did it just purely algebraically, but let me show you how we could have just done it purely algebraically. So if we're trying to integrate, I mean, you might still have trouble figuring out the limits, but assuming you had figured out the limits without drawing it out, let's say we're trying to integrate negative 5 to negative 4 of f of x plus 4 dx. We'll need a negative out the front, but I'm going to leave that out for the moment. I'm just doing the bit inside the bracket and showing how it transforms to this. We could have done substitution. So we could consider letting u equals x plus 4. So that means when x is -5, because it's in x right now, that means u will equal -5 plus 4, which is -1. When x is -4, we would let u equals -4 plus 4, which is 0. And so that then means that this integral will go from -1, because -5 becomes -1, -4 becomes 0. You'll get f of u, and of course you also need to work out du. So du dx equals, just derive that, you get 1, which means du in dx are the same, meaning you'll get f of u du, which, I mean, u is just a variable that you're going to sub in numbers, so it's no different to f of x dx, the same thing. So here we've shown you how, even without doing the drawing, as long as you understood what your limits were, which may not be so clear necessarily, because you can't actually go from, well, actually, yeah, no. So we do know that it will have to be, you will have to treat this under the x-axis. So yeah, we do know whatever your odd function is, it has to be above the x-axis here and below the x-axis here, which means it does have to end up being from -1 to 0, negative, and from 0 to 9. That we do know that. Okay, so once you have figured out those limits, then yeah, you could have just used substitution to do the transformation and not rely on the graph. Well, all you need to do now is basically use this idea, work out the two independently based on what they've given you up here, and do the arithmetic. So let's do that. So we've got area 1 is -1 to 0. So we know that it's going to be e to the a plus 1 over e to the a minus 2. So that's going to be 1 plus 1 minus 2 minus e to the -1 plus e minus 2. So that's a1. a2 is going to equal, well, e to the a plus 1 over e to the a minus 2 a0. Uh, 90, not a0. So that's going to be e to the 9 plus 1 over e to the 9 minus 2 minus 1 plus 1 minus 2. So that will just be e to the 9 plus 1 over e to the 9 minus 2. So that means the total area will equal 1 over e plus e minus 2 plus e to the 9 plus 1 over e to the 9 minus 2. They've asked us to leave it in exact form. So I guess there's not a whole lot we can do here. It's going to be e to the 9 plus e to the minus 9 plus e plus e to the minus 1 minus 4. And there is not too much we can do unless they've asked it in a particular form. They said exact form, so that's what we would have. And that's how you do the question.